Welcome back. In our previous sessions, we performed several important measurements using a half-wave rectifier circuit. Today, we will extend our exploration by using a full-wave bridge rectifier to conduct further measurements. Problem statement: simulate a full-wave bridge rectifier and measure its rectification ratio. Getting started. Let's begin. First, launch Simulink by clicking the Simulink icon in the toolbar. Click on Blank Model to open a new blank model. Now let us save the model. Click the Save icon. Give your model a suitable name, and then click Save. Add the required blocks. Let's add blocks to the model. Open the library browser. Go to Simscape, then Electrical, then Specialized Power System, and then click on Sources. Right-click on the AC voltage source and select Add to the model. Next, go to Power Electronics and add a diode block. Then, go to Passives and add a series RLC branch to your workspace. Select the diode block and press Ctrl+R from the keyboard to rotate it. Next, double-click on the diode block and disable the measurement port. Click OK, as we will need 4 diode blocks, so copy and paste the diode block 3 times. Arrange the diode blocks so we can connect them properly. Rotate the series RLC branch and connect it at the output of rectifier. Double-click on the AC voltage source to open its settings. Set the peak voltage to 311 and the frequency to 50 Hz, then click OK. Open the RLC branch and select R from the drop-down menu. Set the value of resistance to 10 ohms and click OK. This is the complete circuit of a single-phase full-wave bridge rectifier. Measurement setup. Go to the library browser. From Sensors and Measurements, add a current measurement block, a voltage measurement block, an RMS block, and a mean block. Now, connect the blocks. Place the current measurement block in series with the load resistor. Place the voltage measurement block across the load resistor. We need to measure the RMS and mean values of both current and voltage. Make the connections according to the formula. Open the mean block and set the frequency to 50 Hz. Copy and paste both the RMS and mean block and connect each to the output of the voltage measurement block. We'll also need 2 product blocks. Go to the Math Operations section in the library browser. Add 2 product blocks. Also add display block to the model. Connect the mean voltage and mean current to one product block. This gives you the DC power, VDC into IDC. Connect the RMS voltage and RMS current to the second product block. This gives you the AC power, VL into IL. Let's bring a divide block from the Math Operations. Open the divide block and reverse the order of operation. And click OK. Next, connect both product blocks to the divide block to get PDC over PAC. Let's rename the display block. Let's add a power guide block to our model. Open the power guide block and select Discrete from the drop-down menu. Reduce the sample time for better accuracy. Click OK. Next, set the simulation time to 0.08 seconds. Click Run to start the simulation. Troubleshooting. This value is not close enough to the textbook value. Let me recheck all the blocks. I may have made a mistake. Oh, we did not set the frequency to 50 Hz in the RMS block. As the system frequency is 50 Hz, we must set the frequency of the RMS block to 50 Hz. Do the same for the other block. Let us also check the source frequency. The frequency is 50 Hz. Click Run again. Percentage conversion. Let's find the value in percentage. Add a gain block to the model. Connect it at the output and set its value to 100. Now we will have the rectification ratio in percentage. Click Run again. Let us confirm our value with the textbook. So, our value matches the value in the textbook. Summary. In this tutorial, you learn how to build and simulate a single-phase full-wave bridge rectifier using Simulink. We performed key measurements of DC voltage, DC current, RMS voltage, and RMS current, and use these values to compute the rectification ratio, which is a measure of a rectifier's efficiency. Your task: repeat the same process for a half-wave diode rectifier. The expected rectification ratio for a half-wave rectifier is approximately 41%. Thank you for joining us. See you in the next tutorial.